Hey, everybody. Dave Lindbergh in Hong Kong with another episode of THD Podcast number 31. Today, of course, as always, we have Simon in Japan. How's it going over there, Simon?
Super good, Dave. Super good.
Super good. Great.
Yeah.
And our guest today, calling in from Los Angeles area, Rick Fung, the CEO of Nanoflowx. How are you doing today, Rick?
I'm very well. Thank you, David.
Okay. So a lot of people watching are developing audio products, etc. And a classic problem is sweat or water damage on your Bluetooth or portable devices. Now that your audio products are leaving the home mostly, going with you, especially all these Bluetooth headphones, the desire to protect them is a big deal. There's a lot of ways to protect your products, and coating the circuitry to prevent corrosion and damage is a big deal. And Rick's company in LA specializes in that. So Rick, maybe you can tell us a bit how the business started and how you guys execute this protection.
Yes. So we started back in actually R&D in 2013. So when we started the R&D, and at that time, a lot of devices were not really water resistant. I think anything that was water resistant, they were using like these little covers for the charge ports and trying to do gaskets and call them active phones. And not much was really development and not much development in the nano side. So we looked into this and we thought, wow, let's there's a huge market space, especially with a growing market of connected devices that we foresaw. And we thought, hey, we got to create a coating that can replace traditional conformal coating, make it a lot easier than that very old technology, and also vapor deposition, which is very high capital cost upfront to do that sort of protection. So that's how we started. Okay.
Now, when you refer to conformal coatings, that's kind of like the old method of putting like epoxy or thick glues. Like if somebody took apart their refrigerator, they might see that kind of, like a 1-inch thick chunk of glue inside some lighting that needs to be protected inside that environment of a fridge. So that's kind of like what most people think of conformal. So a thick kind of chunky protection. And then the vapor deposition is kind of a very complex approach where they use like plasma to deposit. Is that how it works?
Yeah, the traditional is all like resin or silicone based. So you see this really thick coating, and the issue with those is you have to mask all the components, anything you can't, any connection points, and like just to do a computer Pcb board, it takes 30 minutes with like a magnifying glass and very professional training to cut all these little tape pieces out and stick them on. Mm-hmm. There are machines now that go around the components, but still you can't rework any damaged chipsets or anything. You can't replace them. And plasma is the same thing. It's a huge chamber, like maybe $400,000, $500,000 investment for these chambers, and yeah.
And in fact, that sounds like a big investment. Do we really hear about brands that are successful with their coating because they use that expensive approach? I don't really notice that Beats or Jaybird brag about using those processes for achieving exemplary results. It seems like a big expense with little result.
Yeah, like I think the biggest I think people are just used to what they know. So, I mean, to this day, traditional conformal coating is very popular. The first thing people ask for is, oh, I need a conformal coating because I think that's what I need to do, make anything water resistant. Mm-hmm. Whether it's a plasma process or anything, they're just looking for options. We're still fairly new. Like our concept is much quicker, easier, cheaper, faster to use. And it's all DIY, which is the great thing. And yeah, so I mean, in comparison, we're still fairly young, and we're getting our word out, and that's okay. The biggest.
Yeah, maybe you could run through some slides for us to help give people some visual context to what we're talking about in terms of process and the business.
Yeah, right. Sure thing. So let's see here. Can you guys see this? Is it full size?
No, I think there's a little button on the bottom right there by the zoom slider.
Maybe I am screen sharing. Let's do this. How about that one?
There we go. Perfect. Thanks.
Okay, great. So this is kind of what we do. Nanoflowx, we develop custom formulas for to coat electronic devices to make them water resistant. We're not, we don't have just one off the shelf product. And what we're trying to solve is protection against these common elements that affect PCB devices, where it's dust, liquid, humidity, bacteria, and gases that create corrosion on the electronic device and start to cause them to fail. Even through gaskets will shrink and all this environmental stuff will get inside gaskets. So that's kind of what our approach is. And we created this product. V2 it was our first product, and it's very simple. Our business models, we ship the solution to a manufacturer, and we basically teach them how to integrate it into their processing line and assembly. The coding is very quick and easy to use. Some of the benefits: increasing reliability, durability, reduce downtime and warranty, as a value increase the value of the product by making a water resistant rating or providing water resistant rating. And also finally, increasing the product life cycle, reducing electronic waste, and that's kind of what it does.
Is there just out of curiosity, Rick, is there any reason that your first product was called V2 instead of V1?
Well, we actually have a V1, and we use that for a separate machine that we do, a small plasma machine for cell phones. Okay. But that process, again, is dated. It doesn't offer enough protection versus this product where you just dip the entire thing. Okay. And you get complete coverage from it. Mm-hmm. And this is new for us. So this will be a patent pending feature that we've just added. It is actually utilization of microcapsules. So in this blue section here, imagine this is the actual coating over a electronic device. And inside this coating, you have all these little balls, these little capsules. And these capsules, we can fill them with any solution we want. And we can add more V2 coating, a different antimicrobial or a corrosion inhibitor. And what happens is if there's any sort of abrasion on the coating, whether it's physical or chemical, these capsules will then pop and it releases the coating, and it then self-heals the coating in that sense. So that's how our self-healing technology works. And here's an example of a piece of metal that was subjected to a soft wall chamber for 20 days. And you can see the difference. We've increased durability by about 50% right now. And in about 6 to 8 months, we'll have a product that will increase durability by 200%.
So 20 days in a salt fog test, that's a lot. That's 20 days times 24 hours.
Yes.
Wow.
So I think the one on the left has no
coating,
and the one on the right does. Is there a scratch down the middle demonstrating that self-healing?
Yeah, we scratched it so we can accelerate the corrosion process, exposing the innards of it, and that way you can see how our coating. You see very little corrosion on it. It depends how the salt fog sprays. That's why you get certain spotting in certain areas.
Right.
Okay. All right.
And here's the application process. And this is why we always say we're kind of the fastest coating. You take the device and dip it in a solution for 5 seconds. You can technically spray it, but we highly recommend a dip because it saturates the entire PCB board. And then you just simply apply heat at 80 to 100 degrees Celsius for 2 minutes on each side if you're using a heat gun, or you can set in a curing oven, a heat tunnel, and run high process production for this dipping process, and you're done. You have an IP67, 68 rated.
So the curing ovens, those are pretty standard kind of reflow ovens that would be used for other surface mounting processes. So most factories doing the printed circuit board assembly would have this kind of equipment in-house.
Yes, they would. It literally is just an oven with a fan inside, and it just circulates the air, but they're relatively inexpensive, and most of them have it.
Does it have to hit a temperature to cure?
So the higher the temperature, the harder it gets. It gets to a 9H hardness on the coating. Our operating temperature is minus 60 to 250 degrees Celsius once it cures. And again, the issue with applying higher heat is the circuit boards themselves won't withstand almost anything over 120. So the components will start to degrade. So we kind of lower the temperature.
Okay, so but it's more than just drying it off. You actually have to hit it like an activation temperature.
Yeah, and the reason for this, the heating process, is imagine you're coating a PCB board like you see in the photo here. You're going to see a lot of, especially when dip, you're going to see areas where it's going to be saturated and have pooling. And the heat's going to create this where it's going to cure properly. So we want to create a proper SOP, right? If we're processing 10,000 boards in a batch, we want to make sure every board's going to come out equal. And without doing a heating process, we're not sure which area is going to still have some pooling remaining, but the heat will take it all away and ensure it's all equal there.
What's the viscosity like? So if you do a dip, do you have to let it drip dry for some time, or the viscosity is quite low, so it runs out?
It's the very lowest viscosity. It'll creep into everything. As soon as you dip it, you would drain it in a 45-degree angle for literally 1 to 2, probably 2 to 3 seconds, and then you can set it in the oven. Yeah, it has a self-leveling feature to it. So,
okay.
Yeah. So unlike spraying, where a lot of companies use a spray process, you're going to see a lot of potential for pinholes where it's not sprayed very evenly and it doesn't cure, and you see all these little dimples all over the PCB board. Yeah, we don't have that issue.
Yeah, I've heard a lot of people ask that question about pinholing with many different processes. All right, let's keep going.
So here's kind of how traditional conformal coating looks, right? Very thick, not workable, and limited to scale. You have to mask all the connection points. That's kind of how traditional conformal coating looks. And this is what vapor deposition process is. You need this massive machine. It costs $400,000. It takes 2 to 4 hours. It also not reworkable, and you limit scalability of production. So imagine how many units you need just to coat Apple phones, which sell about 100 million phones a year. You're going to need quite a few of these machines just to do that process. And it's probably not equal because of the different batch loads you have to do. So scalability is a huge issue. And also batteries become affected when you set them in a vacuum.
Mm-hmm. Yeah, I think at one of the locations for the Beats production, they have an entire floor dedicated to those machines. But that's why I mentioned at the beginning, we don't actually hear that Beats are well known for being robust against weatherization. So I was wondering, what's the upside besides, you can brag about spending too much money, I guess.
Yeah. So, this was good this was new technology. People saw something that was new and innovative and thought that maybe this would be a good idea. Mm-hmm. But again, you don't get it. The coating's so thin, right? You're at 100 nanometers to about 200 nanometers, and that's doing multiple layers of coating. Mm-hmm. So because the coating's so thin, you don't even get a dust rating on there. And with our coating, we're about 500 nanometers to about 1 micron. And you do kind of require that coating thickness for durability.
Okay.
So here's just something simple to compare. I mean, we're, again, cheaper, very low overhead to start. It's $5 investment to potentially $60,000 if you scale with a robotic arm apparatus and custom jigs for high volume production. We're talking about, I think, anything over into the 100,000 PCB boards a month, you would make that kind of investment, but no mask required. And we're coating times the fastest, reworkable, and anyone can do it. Very little training. I mean, I can hand it off and all you need is a glass bowl and you can coat almost any device in literally 2 minutes with a heat gun.
And it looks from this that the process would be very scalable in terms of a small factory. There's no real barrier. So if a big brand like a Harman had one factory doing a specialized limited run product, that factory could incorporate the technology, as well as another Harman supplier doing high volume. They could have the exact same process across all the vendors. So
yes, that's exactly right. And it's just like if Samsung, number one, mobiles device manufacturer in the world, they sell 200-300 phones a year. I mean, can you imagine how many facilities they have to make this out of, right? We can introduce this process integrated with very little cost, very little capital cost and training, and the process would be integrated anywhere, right? You don't need technical training. Anyone can adopt it. Managers can then really introduce it to any facility they have, whether it's in Asia, Taiwan, or Vietnam, very easily. Yeah, and our product's non-flammable, so we can put on a plane and ship it easily. We've been doing a lot of that for any other production.
Okay, and the chemistry's made in the States, is that correct?
Yes, we make everything in the United States. Yeah, so this is one of 40 coatings we offer.
Okay.
Go into the masking a little bit. So you say it doesn't require masking. You're talking in terms of covering sockets and connectors.
Yes. So an example to that, a lot of the coatings you have to mask because it affects all the connections after you do a coating process. With ours, it doesn't. Our coating is just thin enough where it allows the power and data to transfer through. So RJ45 jacks, micro connections, USB ports, RJ232, fiber optics, those have all been tested. We haven't had any issues with those at all.
Oh, so what you mean, there's actually enough conductivity through the coating?
Yes, there is. It's funny, and a good example, we coated a camera, a PoE camera for a large electronics manufacturer. And we actually gave them a little bit of solution when we returned the device back and told them, hey, make sure you coat your RJ45 because they're going to plug it in and power it up. Mm-hmm. Well, they forgot to do that, and they threw the camera in water. And 15 minutes later, during their test, the feedback went and burned their $1,200 switch. You have to, when you coat one side of the device, you have to coat the other side. You can't have a finished product if one half of it's not treated.
So you mean the socket end? So let's say you have a PCB with an RCA socket on it. I think you showed one earlier. Do you mean the end user has to coat their RCA plug?
Yeah, we recommend coating the plug. And if you want it even more robust, they can put one more drop after it's connected to seal around it and prevent any dust or any moisture liquid to even enter through that way, because any drop will be hydrophobic and just bead right off. But yeah, we are coating military Air Force rugged servers, and they were exposed to 300-hour salt fog while running. And we coated the entire SSD hard drives, the NVIDIA GPU cards, all that, and had zero effect. They were running a Parylene product, and the Parylene product would fail after 100 hours. And it goes back to the same issue. Parylene can't coat the connections.
Right.
Can't coat the connections, so they would fail very quickly. And we even coated. There's a funny thing about that story. We actually coated the exterior metal casing of it as well, and they gave us every component except the screws. So the only component that rusts were the screws, and it showed this little like kind of a corrosion bleed, like a teardrop off of every screw. And I told them, next time send me the screws and I'll coat those too.
Okay, and reworkability, do you mean you can just burn through it with your resolder?
Yeah, you just unsolder the component and resolder a new component on, take a pipette and put a few drops around that reworked area, heat it back up, and you're done. You don't have to recoat the entire PCB or anything else. Just recoat that reworked area and you're done.
Okay.
All right, very good.
More slides? Did we get to the end?
I think that's the end. I mean, we have, my other slides would be test results, videos, and who we're working with, but yeah.
So then in terms of coating thickness, you mentioned 500 to 1 micrometer.
Yes.
Can you control that? Does that just come down to the viscosity or surface tension of that solution?
Yeah, so to get to 500 nanometers, you're going to have to spray. The spray coating will make it much thinner. And then the dip coating, we average at 1 to 2 microns.
Okay. And are people wanting to go thinner or thicker, or it doesn't affect too much?
It depends on the customer spec. So we can go up to 20 microns, and it really comes down to what the customer's expectation is in terms of durability, voltage. Higher voltage, we need thicker coatings. More durability, more salt spray, we need a thicker coating, things like that. But we've had, people always ask us about durability, how long it lasts. It depends on the environment. We donated a TV. So we bought a Samsung TV from Best Buy. We coated it and donated it to a battleship that's docked in Long Beach, California. Well, it's been there for 5 years. Subjected to salt air and things like that, and it's still operating.
Yeah. Okay, so that's 5 years. Do you have some sort of figure on what the lifespan of that coating is?
It's hard to say because it has a 9H hardness. We have to physically abrade the coating to take it off, or use a solvent, and it's hard to clean off by physical abrasion because after you dip it, it's everywhere on that board. To scrape it all off is going to be very unlikely. You can use a solvent to remove it. It will not completely remove. We designed it to stick and last long. If a customer wants it to not last as long, we can make a formula for that, but then it affects the IP rating. Like the IP rating would likely be IP65 or an IP554 in that sense.
So a lot of the, let's say, I'm going to take the example, true wireless stereo earbuds PCB, it's going to have a MEMS microphone on it. Do you need to mask off the microphone port? So
we did a test with a large audio company. We can't say who, but we didn't mask their microphone. And it was funny. They've tested everything, 3M Novak, Parylene, HZO, P2I, all the other products, and they didn't believe our product. They said, we've tested everything. Your dip process is going to kill our device. This is a waste of time. I said, give me 5 minutes. Let me code it. I only need 5 minutes of your time. So I coded the device, let them. The next day, they wrote me an email that says it works. They were so surprised that it didn't affect the microphone. All the specs were in range. And this was the same thing for a LED manufacturer. They're like, this is going to block the lighting, refractive lighting, and all that stuff. And we told them, again, it's the same story. I only need 5 minutes to coat your LED board. And they ran an in-house test and then sent me the report and says, wow, yeah, very little deviation and completely within spec. So yeah, we're very proud of our product. We've done 8 versions of it to get to today. And we have this new version with reworkable self-healing. So
on that microphone one, do you think it's because the solution didn't flow into the microphone support, or because it did and it didn't affect the microphone performance too much?
So there is a process. We're not going to assume it doesn't. Once you dip it and it goes in, we kind of heat it right away. And the way we heat it, we kind of turn the air a little higher so it blows straight through. Mm-hmm. And that way the coating doesn't leave kind of like kind of like an air pocket in there. Yeah. With the coating. Yeah. So we do it that way. Just like Apple earbuds, we can coat that immediately. I can take any earbud from anyone right now, dip in our solution and heat cure it. But the heat curing, we turn the fan speed up a bit more just to blow right through it and make sure the coating goes inside the device. But yeah, we've coated Apple earbuds easily.
Just the complete product dipped into the liquid.
Finished product. Yeah, an actual finished product. Hearing aids, we do the same thing. It takes, again, 2 minutes for each device.
Does it impact the cosmetic at all, like the look of the finish?
No. So after we dip it, we wipe it. We wipe it off because the coating is very thin. It sometimes leaves a rainbow effect depending on the color of the plastic. But after we dip it, we kind of just take a microfiber, wipe it off, and then we heat it, and that's it.
Okay, very cool. And it
so
sounds
that would also be quite interesting. Sorry, cut you off, Dave. Be quite interesting in terms of speaker drivers. If you can take a speaker driver and dip that, how much liquid gets inside, and how does it affect the performance?
Yeah, so I guess the speaker drives, we've done that on Bluetooth speakers, like assembled ones. And we don't have the equipment to test the acoustic difference on it. To us, on the naked ear, we didn't hear a difference. And then we would then submerge it in water, and you can see it, the music, kind of have that bubbling effect on the water, where the water kind of jumps up and you hear all these beats and stuff like that. So we've seen that playing underwater. And we take it out. We've done it a few times just to cycle through and see how well it performs. And it performed pretty well. So that was good. And we've done drones. We've done DJI drones, Mavericks, and they have very sensitive gyroscopes that a lot of companies say they've done coatings where it throws the balance off. It didn't happen for us. We've done drones with larger industrial commercial drones are $50,000, $100,000 to DJI Mavericks to very cheap $30 drones, and we've had zero issues.
Okay, and location-wise, people can find you besides Los Angeles. Where else do you have offices?
Yeah, Los Angeles. We have an office. We've started here. We're in LA, and we have a office in Dongguan, China, in Changping.
Good place.
Most of our clients are US, and they wanted a service center in China. We were supposed to open an office in Taiwan because a lot of production kind of shifted that way. With COVID, we had to delay that, and we're likely opening it an office this year if we can travel. But we have a partner, potential partner distributor there who has a blending facility for us.
Okay. And so Nanoflowx is just kind of the solution focused on electronics, but the company as a whole does all kinds of surface treatments, coating solutions for a wide variety of products, right?
Right. We like I mentioned earlier, we have almost 40 different coatings, and it's all dependent on substrate. You have one single unit coating for substrate. So we have a coating for fabric, one for glass, concrete, paper, solar panel self-cleaning, metals, paint, and just one for everything. We're starting actually to develop a anti-COVID surface protectant that would, once you can spray, say, door handles, it would last up to 9 months to 12 months. Yeah, so things like that.
Okay, sounds like quite a wide potential customer base. That's pretty cool.
Yeah, we took our base formulation and started to spread it across the board for different products. We just kept getting inquiries. And now with our new self-healing component, there's even more interest in that because it increases durability so much. So we're integrating that into every product soon.
Okay. And if somebody wanted to try out the coating, what's your recommended approach to testing out the solution on say
Yeah,
like
we have a service. Again, our business model was we can do coatings. I mean, we have the capability if someone wants to send us their products, they don't want to do the coating themselves, or they don't want to handle it or have the equipment, we can do it. We have that service. We can do it in LA, we can do it in Dongguan, China, and we also have a sample kit they can purchase. It's $200. It comes with a Pyrex glass bowl. It comes with some 200 milliliters of the solution, funnels, and gloves, pipette, everything you need just to do a sample dip. And the great part is after you dip it, you take the solution from the bowl, pour it back in the bottle. We do zero waste. You can reuse that solution for up to 6 months until you're done with it. So, yeah.
Okay. All right. Yeah, it sounds pretty straightforward method to protect the electronics. Simon, did you have any more questions?
Sure do. Hey, Rick, do you have a background in chemistry yourself, or is there someone hidden in the background who's the chemical expert?
Actually, I don't. I first looked at this. People always ask how I got started. I was a CFO for a company I grew from 250 million to 700 million, a food company. And at that time, we're spending $250,000 a month on repair and maintenance for electronic devices, VFDs, PLCs, HMI, because food plants have a sanitation process. They have to run 100 PSI hot water and quat chemicals to sanitize and disinfect all these equipment. And we thought there has to be a better way to protect these devices. And that's when we looked into like nanotechnology back then. And it was still fairly new with nanotechnology. And we started playing with it. We started developing it. So we had a team, we put a team together and put the solution together. Our coating's not patented. We've proprietized the coating because as soon as you patent the coating, we had to release the formula. And we didn't want to share the formula with the world and have people knock it off right away. So yeah, that's kind of how we started.
So it grew out of this previous company?
Yeah, it was a previous company I was working for, and I left the company and then continued to pursue this. It was a lot of R&D, a lot of, testing and failures. And we went from, honestly, it was from flammable to high odor to having a very yellow product to now it's finally odorless and completely clear and non-flammable. It was a process. It was quite the process.
And at what point did you think, after what period of time did you think that it was really viable?
Well, actually, it was through some validation. We started getting clients using it, and we kept getting feedback about how we needed to improve. I mean, to this day, we don't stop improving. I think one of our next target, since we increased, we're having self-healing features, to have a UV inhibitor to extend the feature of having the UV inhibitor in our self-healing coating. Currently, we haven't bind that product into it yet, so that'll be our next step. And but yeah, we're always we are in development of a new electronics water-resistant coating with a graphene combination to protect EMF and EMI and things like that for the U.S. Defense Department. Again, we do have defense contracts, so yeah, we're developing this also.
Fantastic.
So that could be used for like RF shielding inside like a phone housing, perhaps.
Yeah. So heat dissipation, RF shielding, all that. Yeah. So we're currently in development of it, and yeah.
All right, we'll have to come back and talk to you when that gets launched. I think a lot of the Bluetooth headphones and those kind of guys would be interested in an ultra thin shield that they can just dip onto inside of a housing.
Right, but look at how chips are. Right, chips are getting smaller. They want more heat dissipation and things like that. And I think this product we're developing, we can kind of kill almost 3 birds with 1 stone. So yeah, looking forward to finalizing that.
Okay. Sounds exciting. Anything else, Simon?
No, it's fantastic. Thanks, Rick.
Okay.
No,
All right.
you're welcome. Thank you.
Okay. So everybody, please do the old like, subscribe, share, comment on this video. And thanks, Rick. Thank you very much for joining us today. We really appreciate your time.
Yeah, thanks, David. Thanks for having me. Thanks, Simon.
Thanks.
Okay. See you, everybody.